Okay, so now we talk about how the fluid and what dehydration is and stuff, and how the fluid kind of goes between the different zones. And why is that important? Because really what counts is the fluid that you have in your vein. That's the one that really brings oxygen to all the cells and stuff like that. I mean, extracellular dehydration is important as well, but really what keeps your blood pressure, keeps your heart pumping basically and stuff, it's what's in your vein. That's really what's outside the veins. So, in a good example of this is that in critical care, so for example, if you have someone that has burns or what we call sepsis, so that means someone that has a really major bacteria in their body that makes it very nasty. And what happened is that all those vascular are a larger gap, and those gap the water goes away, and basically they're leaky vascular system. And what happened is what we call third spacing. So the fluid goes into the third space. So it's not into the intravascular. It's not in the cells. It's in the extra cellular, which is extravascular. And so that fluid is totally useless because it's neither in the cells, which makes it functional, and it's neither in the vascular, so which doesn't provide oxygen to transport. So it would be a little bit like closing the highway and cutting all the kind of short streets all over the place, and having all those cars that are transporting, like let's say FedEx or something, and they're all stuck in this parking lot somewhere or in a small place that has a big loop in a cul-de-sac, and they cannot go anywhere. And so all the package that you really need to get it delivered to your, they cannot work. So the highway are closed, and so the packets cannot get to the the place where they get processed, and the process plant has no more package. Why? Because they don't have any package to process. So that's a little bit the same kind of concept of that. So in third spacing, when we give a lot of fluids, if the fluid is not in those two things, mostly in the cell and intravascular, is useless. So so first of all, our skin is very impermeable, is very waterproof, and it's actually the biggest organ we have in our body. And this is why if we didn't have like all the skin that we have, we would have like major infection and stuff, because that's a major barrier to infection, fluids, environment and stuff. It's really like an amazing feat of nature that we have that. And so what happens here is that the water, even if you lay down in that pool, no water would really go in. I could maybe if it would ever, for example, by osmosis, but I don't think it would go through. But even if it would, like for example by maceration or something, it would find its way somehow into your body. It would be extracellular, and so basically that fluid would just basically be outside the intravascular and would be totally useless for our dehydration case here, because what you need for dehydration is you need your fluid to be intravascular or intra the cells, so to be functional. But now the fluids would be all over the place, as well as usually associated with dehydration is that you didn't have any food, or if you're in that dire situation, if your albumin is very low and if your other proteins are very low, it's not pulling any water And so basically that's osmosis that we were talking about. The shift will kind of happens, and either your artery will open up, and then some of those protein will go, because you were saying, well, Daniel, you were talking about osmosis pressure. Well, now that osmosis pressure may be switching, because those leaky artery that we were talking about, as cells die, so if when you get into organ failures, those leaky stuff leaks, and basically the soup now is not as compartment like as it was. A lot of the walls are broken down, or they have a lot of big holes inside, and so bigger cells that couldn't traverse before are now on the other side and basically pulling the water the wrong way. And this is why, for example, in sepsis and burn is the best example of third spacing in fluid. And in the case like you were mentioning, to stay in there, first of all, the skin would mostly stop it, and anything that would come in would most likely go inside the in between the layers, or extravascular, so basically wouldn't be useful for the body. Also, whatever they have in there, the osmolarity could be even higher or change, and so basically now you could even dehydrate more. And this is why we cannot drink water from the sea, is because of that osmolarity, because it's like pure salt. And so by drinking this, you literally take off a lot of that fluids coming out, and instead of staying into your veins, it kind of goes on the other side. Plus all the shutting down of your kidneys and all that stuff and everything because of the concentration. But mainly the big picture, that's what it is. And so that's one of the reasons that tactics wouldn't work. One of the tactics that a lot of people were talking, I'll talk in part 3, but they were talking about enemas and all that stuff. But that too has his drawback. But yeah, so basically the fluids, if would go in, and I don't think it would go to the wrong spot. And if people would say, well, yeah, but when you have like a drowning victim that have, like, you know, they're all bloated and stuff, this is actually a little bit of different phenomenon, because what happened is that bacteria goes into their body and basically decompose. So they decompose from the inside out, and because they lose, so let's say the bacteria kills your arteries and stuff, all that soup that you were keeping inside your arteries now is released. Plus you have also bacterias that are growing and everything. So that's why sometimes bodies will float, because they have all that air bubbles because of anaerobic bacteria that release all that stuff. But all that soup now is released, and so it creates that osmosis pressure that is quite different. And so that's why body will kind of look fat, like bloated, and water will kind of go out. But it's because of that two things kind of going on. And for people that was like, well, when you take a bath and your skin, so that's maceration. It's totally different. It's a skin reaction, and it's actually bacteria growing. It has nothing to do with water kind of going inside your skin or not. So that's why it wouldn't work. But reading the comments, now in the next section, we'll talk a little bit about a few of the myths that people talk about when they get into those things, and the danger, I guess, of those myths, because they're pretty like they come back pretty frequently. So we'll talk about that. See you in part 3.